This is video 12.4. We're going to talk about some pH and acid-base indicators. So we're going to be on page 14. If you flip there, make sure you have your reference table out. So while things are getting set up here, get that out. Make sure you have it. You're going to flip specifically to table M. All right, table M, which is on the same table, page 6, as the common acids on table K, and then table L with the common bases. So if you look in your reference table, guys, you were given 6 indicators. So you might be thinking, well, what is an indicator? I showed you this in class the other day. And indicators will change color. So they're substances, which typically they're weak acids. And most of them, guys, are natural products. So they actually are derived from plants. And then there are certain compounds in those. And next week in lab, when we do our household acid base lab, you guys are actually going to make an indicator. You're going to do an extraction, and then you're going to go through the whole process of making one. So these are substances, mostly are weak acids that change color. Okay. As a result of a pH change, which we're going to talk more about pH in the next video. So this is kind of the precursor to kind of give us some background info. Indicators are chosen based on their range. Let me rewrite that and make it a little clearer. Range for color change. Okay, so not all indicators are actually going to be good for every single reaction or for testing out every substance. So if you look on table M, and we're going to look at it here a little bit more, you know, if I have something that is dealing with a change in pH from, say, like 8 to 10, I'm not going to want to pick methyl orange because methyl orange is specific for like pH of 3.1 to 4.4. Okay, I'm not going to see any change in the indicator if my pH is above it or below it. So the whole goal is to try to find an indicator that will cover your pH range in a reaction. Now, back in the day when scientists were figuring this out for the first time, it was a lot of trial and error. Nowadays, I've kind of gone through, so any experiments that we're going to do, you guys will kind of, have that background knowledge ahead of time. But it was trial and error originally, okay? So, for example, phenolphthalein, one that you guys have used already and you guys are going to use next week, it's colorless at first, okay, up until a pH of about 8. Once you get to pH of 8, it starts to change a little bit, and it's going to go from colorless to a really vibrant, bright pink at the end of its change in the pH range. So, up until 8, it's colorless. From anywhere from 8 to 9, it goes from light pink, and it starts getting more progressively darkened as you get closer to 9. And then once you're at a pH of 9 or greater, it is very, very vibrant, bright pink. Now the reaction we're going to do next week, the titration, you don't want a very bright pink because that means you've gone too far. We'll talk more about that when we get to titrations. So another example would be something like methyl orange. Okay, it's going to turn red in a solution with a pH that is less than 3.1, and then it's going to kind of become that orange color, kind of transitioning from red to yellow between 3.1 and 4.4, and then it's going to be yellow after 4.4. Okay, so the more basic it becomes yellow. So, all of these pH indicators that are listed here, now these are common ones. There are hundreds out there. If you were to do a Google search, you would find a lot. But these are the 6 most common ones that are used. I would even kind of go a little bit further and say phenolphthalein is probably one of the most common, if not the most. Well, actually, strike that. Litmus is going to be the most because litmus paper, which I'm sure you guys have all heard of. Phenolphthalein, those are 2 of the big ones. And then bromothymol blue, I've used quite a bit as well. The other ones, not as much, but again, they're the most common. Okay, you don't have to memorize this stuff. You need to know where to look, which is table M, and then know what it's telling you. Because I guarantee you will see at least one question on your Regents exam. It's every year they show one. This honestly should be hopefully a gimme problem within it. So litmus, guys, is listed as liquid litmus. It's similar to paper litmus, which you guys may have used before in 8th grade science. You're going to use it next week. And then within the approximate pH range for a color change, what's actually happening here, guys, with all those ranges is that you have a mixture or a blending of 2 colors. So if you're asked to kind of tell what the color is going to be at a specific pH and it's in the middle, do your best to kind of describe what the middle of those two colors are. You guys have all taken art classes. You know, red and yellow when they mix is orange, yellow and blue is green. So red to blue, yeah, that one might be a little bit more challenging. It's probably going to go through the whole color change. Think about the example that I did with the universal indicator, where it goes from like red to orange to yellow to green and then eventually to blue. And notice how the litmus also covers a larger pH range than the other ones. That's one reason why it's a common one, because it's, you know, a huge range versus very isolated, very detailed ranges. So do your best to describe the colors. This range, though, this blending or mixture, guys, it does have a term. It is called the intermediate color region. All right. So do your best to describe it. Most of the time, now I say most, doesn't mean all the time, they're going to give you a pH value that's more toward one end or the other, to kind of, so they don't have to, you know, leave up that ambiguity of kind of you describing what it is. And it could be, you know, oh, is it green blue or blue green? Like, who in the world knows that, and how can you grade that? So it's going to be more toward one end or the other. So let's take a look here at a couple examples. Bromothymol blue, pH of 6.4. So what I will do is I'm going to go to that indicator, and I'm going to look at the range. Well, 6.4 obviously falls between 6.0 and 7.6, but which end is it more closer to? It's going to be closer to that 6.0, which if we look over here, the color change, it goes from yellow to blue. So I would put yellow down here as my answer. It's going to be yellow at that pH. So these problems like this are saying, well, if it's at this pH, what's the color going to be? That's all you have to do. Pretty straightforward. So if you want to pause the video right now and try these next three on your own, go ahead and do so. All right, next one, bromocresol green. Okay, 5.0. So our range is 3.8 to 5.4. So it is more toward the middle, but I would say it's probably closer to the blue region. So I would label it as blue. If you wanted to say something like green blue or blue green, you'd probably get credit for it. Just make sure the blue is in there, because the big distinction here is that it's not going to be yellow anymore. It's moving toward that blue color. Phenolphthalein, 8.5. Now that is dead center in the middle. Okay, so this is one where you would want to maybe say light pink. Okay, because it's pink or colorless. That one's kind of an easy distinction to make, that, hey, you know, it's either no color or it's full-on pink, so it's in between. It's going to be that light pinkish color. And then the last one here is methyl orange. 3.9, so that is right there in the middle. So you may want to call this one. It's pretty easy to kind of say what's the color between those. I would say orange, but it's going to be more of like an orange yellow. So if you wanted to put like orange yellow, you could do that, or just orange would be okay. So again, there is a little bit of wiggle room. Most of the time, I would say they're going to give you, you know, something like this, where if you said orange or you said yellow or orange yellow or something like that. All right. So you guys are going to go on and do practice number 4, color indicator. I can check those answers for you, and if you look in the extra practice packet, there's more in there as well that you can get that practice with it. So until next time, I'll see you guys later.